Well, hello, everyone. Our team here at AquaCal would like to thank each and every one of you for joining us this evening for our first fall heat pump webinar. Historically, throughout the state of Florida this time of year, we hold our events at different locations, but unfortunately, due to the pandemic this year, we were unable to do that. However, by hosting a webinar such as this, we can now invite clients from all over the world. Welcome to AquaCal's 2020 Fall Heat Pump Seminar. My name is John Webby. I'm the Territory Manager for Southeast Florida. And with me this evening,
Mike Fireseats, North Florida Territory Manager, AquaCal Pilot.
My name is Jim Acord. I'm the Territory Manager for Southwest Florida.
And this evening, we will cover key topics such as why AquaCal, what sets us apart, as well as introduce new products that make us the pioneer in the heat pump industry. Now, at any point, if you have a question, simply type that question in the chat box, and we will answer that question as soon as we can.
Tonight, we're going to start off with what sets us apart from our competition. AquaCal has been in business for 40 years making heat pumps, and there's over 350,000 of them out in the marketplace today. Our heat pumps are designed, engineered, and manufactured here in St. Petersburg, made in the USA. Our products are supported by a full-time technical service team as well as a top-notch customer service staff.
In addition, we offer the most diverse heat pump lineup in the industry with over 20 different models, guaranteeing we have a model for whatever your customer needs. Our units are backed by the industry's strongest warranty, and the majority of our units are featured with the patented ThermoLink heat exchanger. This heat exchanger operates at a lower pressure and actually can offer your customers a savings of an additional $300 to $1,300 a year. As history shows, AquaCal is always pushing for the next engineering innovation in our industry. So, on top of our ThermoLink heat exchanger, we were also the first people to bring out an injection molded heat pump that offers a stronger cabinet and longer lasting good looks for it. We're also here to, some of the other innovations we've done is also our super quiet model. Our super quiet, we were the first and still the only one to offer it. And what this means is that you can offer your customer the quietest heat pump in the world. And now to talk about a few more innovations we have is our founder and Vice President of AquaCal Autopilot, Jeff Tawney.
Thank you, guys. John, Mike, Jim. Okay. And again, welcome to everybody for attending. We appreciate your taking the time to spend a little time with us and learn a little bit more about what products we have. I'm going to be talking today about variable speed technology, how it works, why you should sell it. To do that, I want to spend a little bit of time talking about how a basic heat pump works and in comparison to a variable speed heat pump. So a quick review of a heat pump's operation. There's three basic components that are really critical to any heat pump operation and of course, by extension, the variable speed heat pump. Every heat pump, of course, has a compressor. The compressor does what its name implies. It's the pump within the refrigeration system, and it compresses the refrigerant. It moves the refrigerant through the heat exchangers of the heat pump. There are two heat exchangers in every swimming pool heat pump. One is the water to refrigerant heat exchanger, which is the condenser here, which is we call our ThermoLink heat exchanger. It's a titanium tube inside a plastic shell or plastic housing, but it is just a heat exchanger. It's a refrigerant to water or water to refrigerant heat exchanger. The other heat exchanger is our evaporator coil, which is the aluminum fin copper tube, the big air coil that you see on the outside of all heat pumps and other types of refrigeration devices. This is a air to refrigerant or refrigerant to air heat exchanger. It's called the evaporator coil, and these names basically imply what the function is within the refrigeration circuit. So in the evaporator coil, we're feeding in cool liquid refrigerant. The fan is pulling warm ambient air across that heat exchanger heat leaves the warm air, goes into the cool refrigerant, changes the refrigerant from a liquid to a vapor, hence the name the evaporator coil, where we're absorbing heat, converting the liquid refrigerant to a vapor. It then goes into the compressor where it is compressed, its pressure is raised, and consequently its temperature is also raised. So as an example, we're probably coming in somewhere around 90-degree refrigerant temperature vapor into the compressor. When it leaves, it's leaving around 140 degrees. It goes immediately from the compressor into the water to refrigerant heat exchanger or the condenser, in our case, the thermal link. There, the very hot refrigerant vapor travels through the titanium tube while the pool water, much cooler, is flowing over the titanium tubes, and there's a heat transfer from the refrigerant to the water. The process then continues where the refrigerant which entered that heat exchanger was very hot vapor or gas, has now been cooled back down to a liquid, and it comes back over to the evaporator and the cycle continues. So in a nutshell, that's how the refrigeration system works. It's important that, you know, we reference the heat exchangers, both air to refrigerant and water to refrigerant, as well as the compressor. So any efficiency, or the efficiency of any heat pump, is driven by the relationship between the compressor and the size of those two heat exchangers, both the evaporator and the condenser. Simply put, given a constant compressor size, the larger the coils, the more efficient the heat pump will be. So with a variable speed compressor, we are effectively reducing the size of that compressor in relationship to the heat exchangers, since their size remains constant. So we end up with a small compressor, big heat exchangers, which transfers into high efficiency. This is just a depiction of the heat exchangers and the compressor in normal speed, full speed relationship. This is kind of just a whimsical look of what we're effectively doing. We see the compressor now is much smaller, because that's basically what we're doing with the variable speed system, is we're slowing that compressor down, reducing its size and capacity. The heat exchanger sizes have remained constant, so the efficiency goes up quite a bit. By effectively reducing the compressor size in relationship to the heat exchanger, we can see COPs at 35% of maximum speed of the compressor, for instance, as high as 10.5 COP. At 50% of maximum speed of the compressor, we're still seeing COPs of up to 9.2 COP. How does that benefit the pool owner? It's a good question. This is all about energy savings, energy operating costs. To answer it effectively, we probably should spend a few minutes talking about pool heat loss and how we size pools as well. So I'm going to use an example here in our local area, but the concept is applicable in any market that we have that you might be interested in applying a variable speed heat pump to. In this example, I'm looking at a 15,000 gallon pool here in St. Petersburg, Florida. We know that there's 8.33 pounds of water to every gallon, so the math on that means we've got 125,000 pounds of water in that pool. This is important because we have to use that formula, 1 BTU to raise 1 pound of water 1 degree. With 125,000 pounds of water, that tells us we need 125,000 BTUs to raise that particular pool up 1 degree. So in January, as an example, a 60-degree temperature rise on that pool would need 750,000 BTUs over the course of the day. That's the 125,000 for 1 degree times the 6 degree required, nets out to 750,000 BTUs. If we're given an 8-hour runtime available due to the time clock on the filtration pump, the heater needs to be able to produce 94,000 BTUs an hour to get that pool to temperature and maintain it. However, on a milder day in October or May, the pool may only require a 3-degree temperature rise versus that 6-degree rise. Instead of the 94,000 BTUs per hour, the heat pump can get the job done at 47,000 BTUs per hour. So the variable speed heat pump will adjust its output performance to maintain the set point temperature in the pool. So reviewing that a little bit, that's just in recognition of the fact that when we size a swimming pool heat pump for a given pool, we typically are looking at the worst case day that you're going to want to run that heat pump. This isn't really much different than when your air conditioning contractor would size his air conditioning system for your home. Typically, they're going to size the air conditioner to handle the heat load in July or August when temperatures are at their warmest. We do the same thing with swimming pool heat pumps. We size them to handle the heat load required in the coldest day or season month that the customer is going to want to use the heater. However, we also know that typically, for instance, at our market and most northern hemisphere markets, that day is going to be either in January down here in Florida or maybe May in the northern climates. But we know that those coldest days are not going to be consistent. There's going to be many days when the heat demand is much less than that coldest day. That's where the value of the variable speed heat pump comes in. We slow the system down to match the heat demand that the pool is experiencing. By doing that, we raise the efficiency of the heat pump, we still deliver the BTUs the homeowner needs, and the net result is quite a bit of savings for the homeowner. Cost of operation versus a single speed swimming pool heat pump will depict on the potential savings of 40% as compared to a TropicAl single speed model, and a potential savings of 25% as compared to a single speed heat wave super quiet heat pump. So the variable speed heat pump carries a return on investment that justifies the price difference. We've seen that with a lot of consumers these days. People are willing to spend more money up front. The popularity of photovoltaic systems on people's roofs are a pretty good example of that. Typical payback periods for that type of solar investment is anywhere from 12 to 15 years. Geothermal heating and air conditioning is a fast-growing popular system for residential home heating and cooling. The investment point above a standard air conditioning system for a geothermal results in a payback of anywhere from 10 to 12 years. People are buying these systems consistently and regularly, and they're doing so even though the payback is stretched out somewhat as compared to a typical variable speed swimming pool heat pump. You should be able to see savings to pay for its upfront premium investment point within 3 to 4 years maximum. So the consumer is willing to buy that type of product if someone takes the time to, one, present it to them and explain it to them a little bit. These customers are wanting to buy the best efficiency. They're wanting the best in terms of value. They're looking for the greenest solution to pool and spa heating needs. Maybe they just want the best engineering product available. And of course, they're going to get the best customer support before and after the sale. So the savings are real. Potentially real for the homeowner. There is an investment point, but it's easily recouped from the savings of the pool. And as an added benefit, as the system does slow down, it becomes even quieter. So it becomes extremely super quiet as the system moves into slower speeds. I also want to touch real quick on a couple other key features of the HeatWave Super Quiet units. All of them come with the smart microprocessor control. This is a new control for us. It's a full text display, 24-character, 2-line, gives the homeowner full text readout of the status of the heat pump rather than having to refer to codes. So a very, very comprehensive and easy to read display. The units, super quiet units, are included with an AquaTop. The AquaTop protects all the internal components from the elements, which allows us to back that particular unit with the industry's strongest warranty. All of our cabinets are state-of-the-art injection molded plastic cabinets, preventing corrosion, and the injection molding process results in a stronger cabinet design. All of our super quiet units are available in an icebreaker mode. The variable speed unit comes standard in icebreaker mode or heat and cool model. This allows the system to heat spas even on the coldest nights. It extends the swimming season longer than a heat only model. And of course, has the ability to cool water should the customer look for a cold plunge or just taking some of the heat out of the pool during the warmest part of the summer. All of our units come with the ThermalLink titanium heat exchanger, which does maximize flow efficiency, which does lower the filtration pumping cost on any given pool if they're using a heat pump with the titanium or the ThermalLink heat exchanger versus the industry standard out there is what's called a tube-in-tube heat exchanger. We save tremendous amounts of pumping cost with the titanium ThermalLink versus tube-in-tube heat exchangers. And of course, all of our units are PoolSync ready, which we're going to give you some more information about that. And I'll try and remind you again a little later on, but by attending this seminar, you are eligible for a free PoolSync Wi-Fi controller with each variable speed unit. So having said that, if there's any questions about variable speed, we can take a few of them now, and we'll also have an opportunity to ask questions at the end of the program as well. But if there's any questions, I've got one. It says, will the Wi-Fi connect to mesh networks? I guess it depends on what type of mesh network we're talking about. I mean, I'm not sure that I can answer that question. I believe so.
I would say yes, as long as we get a signal at the Wi-Fi antenna.
Right.
Where
So
we want to mount it. Yeah.
if the mesh network is supporting a Wi-Fi system, then we should be able to connect to it. Any other questions?
Jeff, we had another question from Mike at the Pool King. He was wondering if the variable speed unit is a reverse cycle unit.
It is. All of the variable speed units are heat and cool reverse cycle. So you get, with that in our icebreaker nomenclature, you get the heat and cool as well as the hot gas defrost. We have a question that says, what is the distance that the unit can be mounted away from the router? You know, that's a real tough one. It depends on construction material of the home. We suggest, and I've been told that one good way of checking signal strength is using a cell phone.
Yep.
Using your cell phone to pick up the Wi-Fi network at the location of the pool equipment will give you an idea of whether you're going to have a good connection or whether you're going to have problems.
So Chris Morelli's asking if about the projected availability of the variable speed heat pumps.
We are in production now. We've been producing and delivering variable speed heat pumps for several months now. There are multiple units out in the field. We've got single unit applications. We've got multiple unit applications where there are more than one variable speed heat pump on one pool. All of the units with our new microprocessor controller can be paired together, so we end up with a lead unit, and all of the other units then take their operation signals from that lead unit and become followers. Any other questions we have here?
Sure, we've got a question from Adrian. He's asking if we can control the cooling feature through automation. I'll take that one. The short answer is yes, and we're going to talk a little bit more about that later in the presentation.
There's one from Justin, BTU operations and BTU options in the variable speed heat pumps. Right now we have one basic size variable speed heat pump. Of course, the BTUs change dramatically with the speed of the unit, but the equivalent size of the variable speed heat pump in full speed is equal to what you would find with the SQ145, as well as the efficiency levels, about 6.8 COP, and 120 some thousand BTUs at full speed.
Miriam is asking, how does the variable speed heat pump sense temperature variations so that it can adjust the BTU output?
That's a good question. We have two methods of adjusting the variable or adjusting the BTU output of the heat pump. One we call the efficiency mode, the other we call a 24-hour mode. In the 24-hour mode, it's just reflecting that the filtration pump is operating on 24 hours, so the heat pump has the ability to operate 24 hours as well. In that mode, which is set up at the time of installation, it's a simple setup wizard question, efficiency or 24-hour mode. You would select the 24 hours, and in the 24-hour mode, the system will run at full speed until the pool is up to temperature. Once it's at temperature, it will then slow down to whatever speed is required to hold the pool at that temperature. Again, on a cold day, it's going to run a little faster on that day. On a mild day, it's going to run slower. But it is measuring temperature of the pool and our ability, or the heat pump's ability, to hold it there. Real quickly, in the efficiency mode, at the time of installation, the heat pump is programmed to mimic the exact filtration setup time that you have on your time clock controlling your filtration pool. So if you've got it set for 10 hours coming on at 8 a.m. and going off at 6 p.m., you would program the heat pump the same way. Now the heat pump knows two things. It knows what the water temperature is and what the water temperature wants to be, and it knows how long it's got to be able to achieve that. It calculates what BTUs it needs to be running at, or what speed it needs to be running at, to achieve the desired set point in the time that it knows it has available.
Excellent. Jeff, Fred Ross is asking who the manufacturer is for the variable speed compressor.
Our variable speed system is completely manufactured by Copeland Emerson. Everything comes out of the Copeland plant in Ohio.
Question, will the variable speed compressor have lower amp demands for the units? So I think Sean's asking about the data plate rating. Will it require a smaller breaker?
We have to, no, it won't. We have to pick a speed to have the unit rated at, and because we know the system will run at full speed at times, the units will be rated at full speed. So we would still be looking at a typical 40 or 50 amp breaker for this unit.
Okay, well, we've got a few more questions here about the PoolSync. Emilio is asking, is the PoolSync compatible with Android phones? And I will take that one. The answer is yes. There are both iOS and Android versions of the app available.
There's another one where it says, will the variable speed be available in the AquaCal line? And it will not be at this point. You know, it's just my opinion and my prediction, but I think in 5 to 7 years, all heat pumps will be variable speed. But for right now, the only offering we have is in our super quiet line.
Okay, so we have Sean asking, is the PoolSync system compatible with older models of heat pumps? And I'd be happy to take that one. We will cover this in a little more detail, but the PoolSync is only compatible with the current smart controller, but there is an upgrade kit available for older models if they're not equipped with the smart controller. We've got another question from Jim. He's asking if the variable heat pump can also connect with or control a gas heater.
Well, our new microprocessor controller, the HP9, will have that feature available. So by extension, it will be also available in the variable speed unit as well.
Yep. Okay, Miriam's asking, back to the variable speed unit, do we think that the 24-hour mode or the efficiency mode will offer better savings?
Yes. You know, it really is kind of specific to the application. Typically, I would say our studies have shown that the efficiency mode is typically a better mode because it may never run in full speed in the efficiency mode, depending upon the sizing, because it is calculating at what speed it needs to run to reach design set point. Whereas in the 24-hour mode, it's automatically going to run at full speed until you do reach design set point, and then it's going to slow itself down to hold it there. So our testing indicates that the efficiency mode is the most efficient way to go.
Okay.
It's the name.
Dennis is asking if there are any special plumbing requirements for the multi-unit or for the variable speed unit. Anything special about the plumbing?
Not really. I mean, our flow rate requirements are typical compared to all of our single speed heat pumps. So we're not asking for anything less or more. I think we're rated at 20 to 70 GPM, and that's true with single speed and variable speed. As far as plumbing multiple units, every one of those jobs is a site-related answer. Obviously for multiple units, we'd like to see the flow rate in parallel when possible. But every job is going to be a little bit different, and it becomes the installer's responsibility to figure out exactly what needs to be done on the site. Of course, we have an excellent site application engineering support available through our customer service and support department. So if you have specific questions along those lines, don't hesitate to give us a call.
Okay, so Brian's asking if the variable speed unit has a minimum environmental operating temperature, so a defrost quotient.
Yeah, because it is a hot gas defrost unit or a heat and cool unit, we do manage the defrost. So it will run in very low temperatures, definitely below freezing. Obviously, the heat output is going to be diminished dramatically because there's less heat in the air, but it will run well below freezing conditions. Let's see, does the variable speed heater allow a lower flow rate from the variable speed pool pump? Example, can a variable speed pump run under 1,000 RPM and trigger flow switches? That isn't really a variable speed heat pump question. It's really an issue about the heat exchanger and at what flow rates you can operate your system with the type of heat exchanger that you have. So typically with the thermal link heat exchanger, you can run the pump at lower RPM and deliver the same gallons per minute as you would the given filtration pump on another type of heat pump with a tube-and-tube style heat exchanger. So because we have less restriction to flow, you can put less energy into the variable speed pump and get the same flow rate.
All right, so Kenton is asking, can you run the variable speed unit at maximum RPMs for 24 hours? Basically, can you run it full blast to heat up a cold pool or?
Yeah, you can. It will either do that on its own if it decides it needs to, or the customer can hit a boost button. And by hitting the boost button, the unit will go to full speed maximum until set point is reached.
No problem running it continuously though?
No.
No? Okay.
I'd take the opportunity to point out that this technology, one is Copeland Emerson, and it's not new. It's new as far as application to the swimming pool heat pump industry, but this type of technology has been applied to heating and air conditioning equipment for many years now. So we're not breaking new ground with new mechanical designs or components here. We're just applying them, the first to apply them in the swimming pool industry.
Okay, Barry's asking about a winterizing question. In colder climates, when we're winterizing, do we recommend covering the heat pumps?
We historically don't. In colder climates, we do recommend, obviously, winterizing to drain the water out of the system. Other than that, covering the unit any further than that isn't necessary. There's no negative necessarily involved with it, but it's not necessary. It is designed to be outdoors in all kinds of weather.
Okay, so Faze was asking if we can expand a little bit on what's needed for to convert older heat pumps to use the PoolSync. And again, this will be covered a little bit later in the presentation, but basically for older model AquaCal heat pumps, there is an HP9 upgrade kit available. So that kit involves replacing the microprocessor board, the display, and adding a couple additional sensors. And there is a really good video on the AquaCal website that walks you through the process step by step. So most of the conversions that our technicians have done, once they've done one or two, they're doing them in about an hour or so, maybe a little bit more than an hour. So. Okay, well.
Yeah, I think we'll take an opportunity to move on at this point. There will be opportunities for more questions at the end of the next presentation before we wrap up the seminar. So at this point, I'd like to take the opportunity to introduce Matthew Gomolka. Matthew is our technical training manager, and he's going to talk a little bit about the PoolSync as well as some other neat options and features that we've got coming your way. So I appreciate your time listening about variable speed heat pumps, and I'll turn it over to Matthew.
All right, well, thank you, Jeff. And without any further ado, let's take a look at some of the features of AquaCal's smart controller. So we first introduced the smart or the version HP9 controller back in 2018 in our heat and cooler reversing units. So it did become standard on all AquaCal model lines in 2019. So we currently have well over 30,000 heat pumps out in the field using the smart controller. As Jeff mentioned earlier, we have a digital control panel with a 24-character full text LCD display. It gives us very, very easy to read diagnostics and error reporting. So we have the ability to connect to any external controller that has the capability of controlling cooling. So we have full control of heat and cool units, or chill-only units. There's a hybrid functionality that can start a gas heater when we need that extra boost of gas heat. We have a multi-unit mode for commercial sites that have multiple units. And of course, these units are PoolSync ready. So the smart controller is very easy to identify by the full text display compared to the 3-digit display on our older models. The heat pump model and serial number are easily accessible right from the control panel. And if we have a fault, helpful instructions for troubleshooting are displayed. And again, if you have customers that have an older AquaCal unit, the upgrade kit is available, and there's a very detailed video walking you through the upgrade process at www.aquacal.com. So you want to look for tutorial videos under the Education tab. So our smart controller uses RS-485 communication to talk to other external controllers to operate both heating and cooling modes. But we have to keep in mind that not all brands and not all controller models have the ability to control cooling. There's only a few models out there that actually have cooling capability. So you need to check with the manufacturer before you try to make that connection. But if the controller you're using has cooling capability and has an RS-485 connection, the AquaCal heat pump can definitely talk to it and communicate with it. To make our connection, we just simply locate port B on the heat pump control board. And by the way, all the blue connectors on the AquaCal control board are removable. So it makes the wiring a lot easier and helps you to properly identify the correct connection point. On the controller side, we'll have a 4-wire connector, and we're going to use the 2 data connections in the center only. The data ports, depending on your controller, may be labeled data plus and minus, or they may have a number or a letter designation, but we're always going to connect to the 2 center points, never to the outer power and ground connections. And we have another great video detailing the smart connection process on the AquaCal website. The backup heat or hybrid mode can control a gas heater when conditions are beyond the capabilities of the heat pump. So this feature automatically brings on the gas heater only when needed, and it still maximizes the efficient use of the heat pump. There's a 24-hour mode, as Jeff mentioned earlier, usually for systems that have continuous circulation pump operation, typically commercial sites. And then there's also a scheduled mode for systems that have a scheduled circulation pump runtime. The scheduled mode uses that sophisticated algorithm to monitor rate of rise and to anticipate if set points going to be achieved within with the heat pump alone. And a real cool feature with the gas backup is the gas boost feature. So the gas boost feature can be used to very quickly heat up a spa. It actually activates both the heat pump and the gas heater together. It's also useful for bringing a cold pool up to temperature, maybe for the initial heating at the beginning of the season. To make our backup heat connection, we locate the gas port on the heat pump. And on the gas heater side, we're going to use the common and the pool connection, or depending on your model, you may connect to the fireman switch. Basically, you're going to connect this the same way you would connect your gas heater to automation. So it's going to vary depending on your model. And of course, on the website, just like all the other features, there's a very good and easy to follow how-to video on the AquaCal website. So in the past, controlling multiple heat pumps on a commercial site required an optional and very expensive controller. So our multi-unit mode is now a free feature that's built right into the controller. We can control up to 16 heat pumps from a single primary or leader unit. Those heat pumps can be a mix of both heating, cooling units. It doesn't matter, as long as we make the primary unit a heat and cool. The really nice feature about this that gets a lot of dealers excited, when we connect the units in multi-unit mode, all the units on the site that are connected automatically start displaying the same temperature as the lead unit, so no more calibration issues. So to connect our multi-unit mode, we locate port C on the heat pump. And all we have to do for wiring is daisy chain a 2-conductor wire from one heat pump to the next. So no expensive controller, no complicated wiring, a very, very easy process. And of course, we have a how-to video that walks you through the process step by step. So I've saved the best for last. The PoolSync Wi-Fi controller gives us the ability to control the heat pump right through your phone using the PoolSync app. There are both iOS and Android versions available, and this app has a demo mode. So, I recommend go ahead and downloading the app now and getting familiar with it. You can go through the demo mode and get familiar with the functionality of the app. So there is a concise and very easy to understand dashboard that allows you to quickly view the system status. There's a heat pump screen that allows you to control heater mode, adjust temperature settings. And then we've also got a schedule screen that allows you to create schedules that can automatically adjust your settings. So we mentioned earlier, we recommend before mounting the antenna, just hold your cell phone up in the area where you want to mount the antenna, excuse me. And if you've got 1 or 2 bars, you're good to go. So you do want to make sure that you're on the correct Wi-Fi network, the homeowner's network and not the neighbor's. But if you're seeing a couple of bars on your phone, you're good to go. It's an extremely strong antenna. Wiring could not be easier. We locate port D, or our Wi-Fi port, on the heat pump microprocessor. And we connect the 4 wires from the sink as shown here. And then after that, all we do is open up the PoolSync app and follow the on-screen prompts to make the connection. So at this point, I think we'll take some questions.
Okay, we've got a question from John. What is the price of the upgrade kit?
I think pricing questions will have to be directed to your sales rep after the seminar. So keep all your pricing questions directed towards your sales rep, please.
Very good. There's a question from Kenton. Will this be available for 50 hertz models as well? I believe Kenton's probably referring to the PoolSync, and we might as well answer that for the variable speed as well.
Absolutely. It'll be available in both 60 and 50 hertz.
And if Kenton's referring to the PoolSync, that will work, currently will work with 50 hertz models. So anything that's out there, the PoolSync is compatible.
Okay, very well. For the HP9 to control the gas backup, will it also have the ability to activate a valve actuator at the same time?
At this point in time, no.
Here's a good question. I had to step away for a little while. Will we be able to rewatch this video? Will it be available?
Yep, absolutely. The video recorded, a link of the recording will be emailed to anybody who's registered.
What is the demo login credentials required with the PoolSync?
Once you download the app, there really are nothing required. You can just open it up and access the demo mode.
Okay. John, getting back to your question, I'm sorry, I jumped to Barry's. His question is if it's running with a variable speed pool pump, does it need a minimum gallon per minute to run?
Well, we still rate the unit at 20 to 70 GPM, so we're going to need that 20 GPM, yes.
Okay. Scott Fennell had a question, is what will the price at launch? Again, I think we are going to defer to your local sales rep
Yes.
to discuss that type of question. Aswin had a question, is this device, can it be connected to an old model as well?
I think he's referring to the sync or to the HP9 controller. So we did mention that there is an upgrade kit available to convert any older AquaCal heat pump to the current smart controller.
Okay. Okay, I have a heat and cool unit that was installed in 2018, and Chip put in something in the heat to work with the Jandy. Can this be removed and install this new controller? So it sounds like he's asking if we could install the PoolSync as opposed to using the Jandy AquaLink for control of the heat pump.
Just did that at my house this last week, yes.
Yeah, absolutely. As long as it has the smart or the HP9 controller, absolutely.
Fabulous. When will the HP9 controller be able to control valve actuators for a pool spa combo?
Yes. Coming soon, best I can do.
Do they make a hardwired version of the PoolSync for those customers that have horrible internet signal?
Do not.
We do not.
So no Ethernet, direct Ethernet connection?
No direct Ethernet.
If the customers that have a bad signal, what we're seeing most of them do is go to mesh networks or extenders. And most of the cable companies are offering those upgrade kits. So.
Good news. It's a good question. Can the PoolSync work with 5 gigahertz or only the 2.4 gigahertz?
It's going to automatically select the 2.4 or the 2.5 gigahertz. Yeah.
So you want to select that particular network during the initial?
The sync actually does that automatically.
Okay, great.
Yeah, and I would point out that 2.4s typically are really designated for long distance signal strength, whereas the 5 is usually speed. So if you're streaming movies or something like that, 5 is great. If you want to reach out, the 2.4 is the right network to be on, and that's why we select that automatically.
Great, thank you. Another good question is, will the Wi-Fi need to be set up again if the home loses power?
No, it's a one-time setup. The only time it would need to be set up was if something significant changes or they change your password.
Okay, second part of this question, is there service user login capacity?
Not at this time, but I think that is on the drawing board. Yeah.
Okay, great. So that the service technician will be able to access the controls? Okay,
yeah. So I think I misunderstood the question. There is a service mode available, yes. So a technician on site can get in and see that.
Correct me if I'm wrong, but I think we're still doing that on Bluetooth.
Yes.
So yeah, a technician can end up on the site, press the service button on the sync, and connect to the system through Bluetooth on their phone without having to go into the customer's Wi-Fi network.
Yeah.
Perfect. Can't remember if you'd mentioned what size pool and conditions the inverter units can handle.
Well, conditions, I'm not sure what you mean by that. By pool, again, this unit is at full speed is comparable to the SQ145. So whatever you're comfortable with sizing the SQ145 or 120,000 BTUs for, this unit will handle that very well. I will say the smaller the pool, the better efficiency you're going to get out of the variable speed unit. So ideally, if you apply this unit to a 10 or 12,000 gallon pool, you're going to be more efficient than if you applied it to a 15,000 gallon pool, just because the smaller pool volume requires less heat, and therefore the unit's smart enough to know it can slow down and run at a lower speed, higher efficiency.
Jeff, even at full speed, running full out, the efficiency at maximum speed is still pretty high.
It's actually slightly above the SQ145, and the SQ145 is the most efficient heat pump on the market right now. So the variable speed at full speed is slightly more efficient than the standard single speed SQ145.
Yep.
Okay, and then referring to the PoolSync, software and firmware updates, those are available to do over the air, if you will?
That's correct, yeah. They're automatically pushed over the air.
I've got a question of what is the part number for the PoolSync so I can look it up from my distributor's site.
Give us a minute to research that and go on to another question, and we'll come
Get
back
that
to
for you. There's another question here from Ray. Will there be larger units for big pools like a 20 by 40? I think we're referring to the variable speed.
I'm assuming so. Anything larger would end up in three-phase power. This is the largest single-phase compressor available in variable speed currently. So yeah, there will be larger available, but they will be in three-phase power.
Fabulous. Getting back to the part number.
The part number for the PoolSync is ECP0343. And I will say it's very competitively priced.
All right, I think that's all the questions we've got for the moment. We might have one or two more come through.
Well, I really appreciate everybody joining us this afternoon, evening, and giving us the opportunity to talk to you about our new products. I want to thank the team here for their efforts in putting this on. If there aren't any more questions, I would remind you that, once again, I was told to remind you several times about the free PoolSync available for attending this meeting. And I have been asked to also bring up the issue of the bypass. There does seem to be some misunderstandings of the application of bypasses that we recommend for our swimming pool heat pumps. We still recommend 20 to 70 GPM, and anything over 70 GPM or the potential for being over 70 GPM should have a bypass installed. Otherwise, if you don't have that potential, there's no need for a bypass. Our rule of thumb here at the factory has long been if you're over a 1.5 horse pump, 2 horse or higher, you need a bypass. Anything 1.5 horse or less, you don't need a bypass. Now, if you've got a variable speed pump and its full speed capacity is 3 horsepower, you should be putting a bypass on that, because somebody somewhere down the line is likely to set that pump at high speed. So 1.5 horse or less, no bypass. Anything above that, bypass.
And the main purpose of the bypass is to promote good system hydraulics.
Yeah, we're not recommending the bypass to protect our heat pump. The ThermalLink heat exchanger will take whatever you can throw at it for the most part, but the more water you try and push through the heat exchanger, the less hydraulic efficient that pool system is going to be. So it's really the flow rating is geared towards at what point are we starting to create undue back pressure or friction loss on the pool system, and 70 GPM is about the right number for us. Any other questions come through?
Just some miscellaneous. Is it going to be efficient on a 20 by 40 pool at 30,000 gallons?
Not as efficient as it would be on a 20 or 15,000 gallon pool, but it's still going to be very efficient. Absolutely. I can't, it's every job is going to be different. I can't tell you, whether this unit's going to run at 30% speed most of the time or 70% speed most of the time. That's going to depend upon site conditions, which include how big is the pool, but at what temperature does the customer want the pool? In what ambient conditions, what weather conditions are they trying to heat that pool? So there's going to be a lot of factors. If you cover that pool, it's going to change. So can it be very efficient? Yes, but it could also be very inefficient. No worse ever than a standard single speed SQ145. Other questions?
Looks like that's about it.
All right, well, again, thank you so much for your attendance and your time. We really appreciate it. Don't hesitate to give your sales rep or anybody here at the factory a call for support. We've got great before the sales support. We've got great after the sales support. We appreciate your business and your time. Thank you.
Thank you.